In this video, we'd like to visit some of the features of one of the most widely used distributions in statistics, which is the normal distribution. The normal distribution, the probability density function looks like that. Um, it looks complex, but it's pretty straightforward in terms of what are the parameters that drive the probability density function. But as we discuss, you will come across why am I saying this to be simple. So when one thinks about the features, the first feature of the normal distribution is that the normal distribution is symmetric. So the area to the left tail and the area to the right tail are evenly distributed, and the center point of the distribution, which is the highest point of the distribution, the most frequently occurring observation, is equal to the mean of x, or the random variable, and it is also equal to the median and the mode because it's a symmetric distribution. The third feature is that the entire family of distribution, the normal distribution, can be defined by just two parameters. One is the mean and other is the variance, standard deviation to be precise. Uh, and once you have these two parameters, mu, mean, and standard deviation, sigma, one can then just put different values of x and find out how frequently is x occurring, which is nothing but the probability distribution function. So here's the big function. Here's sigma pi is 3.14, e is 2.178, sigma square is the variance, mu is the mean, and x is the different values of x that the random variable takes. And given the different values of x that the random variable takes, the distribution of the probability behaves like what you see on your screen in the red box. So the point is, once we know the mean and the standard deviation of any random variable, we can then plot the entire probability distribution across all different values of the random variable x, just for example. So a mean is nothing but it gives the location on the number scale of where the distribution is located. So it gives the location of the distribution on the number scale, and of course logically, therefore, the mean can be negative, or it can be centered at 0, or it can have a positive center. So here you have a three distribution A, which is centered at -20, distribution B, which is centered at 0, and distribution C, which is centered at 15, positive 15. So the mean is basically giving the location of the distribution on the number scale. The second parameter that defines normal distribution is the standard deviation, and standard deviation measures the spread of the distribution. So how wide or narrow is your distribution of the random variable? So here you have taken example sigma 1, let's say standard deviation is 15, and sigma 2, the standard deviation is 5. You can clearly see when the sigma, or the standard deviation, when the deviations from the center point, are closer, the standard deviation is smaller, the distribution is narrower, so to speak. And when you have the standard deviation to be higher, the random variable takes a far more wider spread compared to the center point. Notice that whether you're talking of distribution which is colored in blue or distribution which is colored in black, both have the common mean of 2. So the center point is the same between the two distribution in this case, but what is different is the spread of the distribution, and that's the second parameter, standard deviation, which defines a normal distribution. So mu and sigma are the two parameters that defines this normal distribution. The sixth feature of normal distribution is that the probability is given by the area below the curve, right? So here you have a normally distributed curve. It is centered at some mu, and the probability is given by the area which is below the curve. So because if you think of the center point as mu, then, and because it's normal and it's symmetric, the area below the curve to the left of mu is half, and area below the right of the curve to the mu is half, right? uh, and so the area below the curve is nothing but the probability of it gives the probability of the random variable. And the last noticeable feature is that when you take the center point and take plus minus 1 standard deviation, it covers 68.3% of the area. The area below mu plus minus 2 standard deviation is 95.4% of the area, and the area below mu plus minus 3 standard deviation is equal to 99.7% of the area. So basically it's saying that almost 99.7% of the probability that the x takes a value will be between mu and mu plus minus 3 standard deviation, right? So when you think about this standard, you have say 0, and so 1 standard deviation minus and 1 standard deviation plus, this area is 68.3%. Then you take 2 standard deviation away from the mean, and that will cover 95% of the probability. And then when you look at 3 standard deviation plus minus the mean,